with the paper of S2, that's Feb March 2022, and there is only one variant. Let's look at the first question. So now the first question is about, let me start labeling. The length in millimeters of a random sample of 12 rods made by a certain machine are as follows. Find unbiased estimates of population, mean, and variance. So now, what is the formulas that you need? X bar is sigma x over n. So add it all up, that is 200. So show examiner all the single piece of work that you do. 200 plus 201 plus 198 plus 202 plus 200 plus 199 plus another 199 plus 201 plus 197, 202 plus 200 plus 199. So add it all up, divided by, there are 12 pieces of info, and you get the value of x bar, and the value of x bar comes out to be 1199 over 6. That's in the fraction form, but I will go for the decimals. So let me get it right. 1199 divided by 6, that comes out to be 199.833. Then it says another formula for sample variance, that is sigma x square over n minus x bar square. So that formula can be used, and this is square each value. So just show a bit of the working. 200 square, 201 square, dot dot dot, all the way till 199 square, divided by n. So what is n? N is 12 minus x bar square. You can use the unrounded value, which is actually 2398 divided by 12. So this is 2398 divided by 12. 2398 divided by 12, the whole thing square, or you can even use this particular value. This is the sample variance that you get. Unbiased estimate of population mean is the same thing as sample mean, and this, after the division, this comes out to be 199.833, which comes out to be 200. That is correct to 3 significant figures. Unbiased estimate of population variance, it's n over n minus 1 sample variance. That is 12 divided by 11 multiplied by whatever this value is, and it simplifies to 2.33, correct to 3 significant figures. Now, again, taking you to the formula booklet, if it's already here. Somewhere here is the formula booklet. There it is. So now you can also use this formula, that is this one, for unbiased estimate of variance. So therefore, some people, actually most people, they use this particular formula to get the answer directly. Now coming back to this, my paper is somewhere over here. So that is this one. Give a statistical reason why the estimates may not be reliable. So now estimation is based upon the sample size. What is the sample size? Sample size is only 12. And does it say that it followed a normal distribution? No, it was not about the normal distribution as such. It's not about CLT. Actually, it's just about the sample size. So this sample size is kind of small. So therefore, it may not be very, very reliable. Question number 2. What is this question all about? It says like a hypothesis test. So that's the first thing. Let me write it. So this one is hypothesis test, and this test is for a binomial probability distribution. Now the question says Harry has a 5-sided spinner with sectors colored such and such. So there are 5 sectors, that's blue, green, red, yellow, and black. Harry thinks that the spinner may be biased. So it's just about the thinking. He plans to carry out a hypothesis test with the following hypotheses. So this is given. That means the probability of any number on blue is either 1/5 or it's not equal to 1/5. So let me first write the info that I have obtained so far. X follows a binomial distribution, and this is 300. That comes up later. And probability of success is 0.2. 1/5 is 0.2. The sample value that is obtained from 300 spins, that is 45 spins. And H naught, it's already given. P equals to 0.2. H1, P does not equal to 0.2. So therefore, this is a two-tail test. Now, this 5% is divided equally, 2.5% on the lower tail, 2.5% on the upper tail. What else is there? Since it's about suitable approximation, naturally it's about normal approximation to binomial. That means let me add a normal distribution curve over here, and let me add the percentages and everything. So therefore this is 2.5%. This one is again 2.5%. The z value for 97.5% is what you are looking for, that is 1.96. So therefore this is 1.96 negative, positive 1.96, and this is 0 in the middle. Let me just do the correction over here, and this is positive 1.96. Now what else do we need? We have to carry out the test for 5 marks. First of all, you would say n equals to 300, P equals to 0.2, Q equals to 0.8. So therefore NP, that comes out to be 60, NQ comes out to be 240, and NPQ comes out to be 240 multiplied by 0.8. So that comes out to be 48. As far as justification is concerned, so justification is based upon these two. So justify. Since NP is greater than 5 and NQ is greater than 5, therefore X follows a normal distribution. What goes in there? You have NP, you have NPQ. Therefore this comes out to be 60, 48. So that is the thing that you achieve, 60, 48. So up till here is all set. Now the sample value is 45. This sample value is inclusive. So probability X is greater than, actually, should we go greater or lesser? That's $1 million question. The sample value is lesser than mean. So therefore we would be focusing on the lower tail, because you have to make a decision about continuity correction. So probability X is lesser than or equal to 45. Probability Z is lesser than or equal to 45 minus 60 divided by square root of variance, which is 48. So therefore, don't use this 45. Wait a minute. I just made a small error. I need one more step over here, and this thing goes down like this. Now let me draw a number line, and this is 45. This is 45.5. This is 44.5. There are two possible scenarios. One is the red one. One is the purple one. So show every piece of working which is the correct one. 45.5 is the correct one. Why? Because 45 is inclusive. So now you have reached this stage. Now standardize. Probability Z is lesser than or equal to negative 2.093 and stop. So now double check, where does this value lie? Negative 2.093, it lies in the critical region. So this is the calculated Z value. What is the conclusion? Reject H0, accept H1. Now write in the context of this question, Harry thinks that the suspender may be biased. So therefore the conclusion is, yes, we have sufficient evidence to support, endorse Harry's suspicion. So whatever Harry's suspicion is, Harry's claim is, we are ready to support it. That means the spinner is biased. So now this is question number 1. Question number 2 that we have done, that was for hypothesis test. Now let's move to question number 3. So let's go to question 3. What is it about? It looks from the face value. It's about confidence interval for proportion sample, and it's about the concept in which you have to find the confidence interval. Yes, exactly, this is what it is. 500 households, confidence interval for proportion P, that owned 2 or more cars was found, and this is the answer. Find the confidence level of this confidence interval. Give your answer correct to the nearest integer. So now, first of all, the thing is, what is PS? Let me draw a number line. So now this PS is the mid value. So this is the lower limit, that's 0.355. This is the upper limit, that's 0.445. In between SPS. So when I calculate the mid value, PS lies halfway between the two, 0.355 plus 0.445. That comes out to be 0.4. So that comes out to be 0.4. Now PS is basically proportion of success. So PS is n goes at the bottom, and that number of favorable outcomes, you can say, that goes at the top. And what are we looking for? We are looking for 500 is already given. So as such, you don't need anything. You just need this thing. And what else? What is the width of the confidence interval? That also you can take. So now I was thinking of a question in which n was unknown. So no, that is not needed. First of all, if PS is this, QS is 0.6 and n is 500 and Z is what you are looking for initially, and then of course you have to think a bit. So the width formula, that is 2Z PS, and let me draw the square root first, PS QS over n. Width is 0.445 minus 0.335. This is 2 multiplied by Z multiplied by 0.4 into 0.6 divided by 500. Now a little bit of calculation is needed. So when you do the calculation, you get the Z value coming out to be 2.054. Now when you go to the table, so if you go to the table and you do back solving, that means, what does back solving means? Using the Z value to find the probability. No, it's not back solving, it's forward solving. So therefore, using the Z value to find the P value, so this Z value 2.054 is giving me 98%. What does that mean? So let me grab my normal distribution table again, and this is how it goes. This is 2.054. And when it says 98%, that means 98% is all the way left and 2% is right. Got the idea? Let me draw the number line now. This is 2.054. It's a symmetric confidence interval. This is negative 2.054. Over here is 2%. Over here is 2%. Therefore, in between is 96%. Therefore, the confidence level of this confidence interval is 96%. So that's how this working is done in a straightforward manner. Question number 4. What does it say? Question number 4 says, in the past, the time in minutes taken by students to complete a certain challenge had a mean 25.5, standard deviation 5.2. Does it say normal? No, it does not say normal. So question number 4, that's the time taken. And then it says a new challenge is devised and it is expected that the students will take on average less than 25.5 minutes. So let me start underlining the time in minutes. Complete a certain challenge. Mean is this, standard deviation is this, expected will take less than 25.5 minutes to complete this challenge. Random sample of 40 students is chosen. The mean time for the new challenge is found to be 23.7. Assuming that the standard deviation is 5.2, so it's still 5.2, test at the 1% significance level whether the population mean time for this thing is less than 25.5 minutes. Now I don't see normal distribution written anywhere. So this is hypothesis test, and this is a scenario of CLT. So first of all, you would say since n is greater than or equal to 40, therefore CLT applies. That is the first thing that's needed. Now when CLT applies, you would say x bar, let me first write x. X follows a normal distribution, 25.5 and 5.2 square, 25.5 and 5.2 square. It is a sample mean question, therefore divided by 40, and that is this 40, actually this one is 30. So sample is large, that is 30, and sample size is 40. Now hypothesis test, the percentage is 1% significance level. H naught, that is mu equals to 25.5, H1 mu is less than 25.5, and the sample value that's given in the question, that's how much? 23.7. Now let's calculate the z value, that is x bar minus mu sigma square over n under root, that is 23.7 minus 25.5 divided by 5.2 square over 40 square root, and from the calculator it comes out to be negative 2.189. Now this is the third time I'm using the normal distribution table. So S2 is all about normal. If you can get hold of normal in S1, you are equally comfortable in S2. So now this is 1% significance level. It's a lower tail test. Z value is negative 2.326. This calculated Z value lies a bit on the outside. Therefore, do not reject H0, accept H0. So we have insufficient evidence to do what? What was the question all about? A new challenge is devised and it is expected that the students will take less than 25.5 minutes. So basically that test of reducing the time, we don't have data for that. We have insufficient evidence. Insufficient evidence to accept that the mean time has decreased. So that is the working for this one, and that's how this question is done. There is also another method, that's the X bar method, but there is no use as such. The easiest method is the Z method. Let's keep life simple. State with a reason whether it is possible that the type 1 error was made. Now the rule is type 1 error is made in rejection region and type 2 error is made in acceptance region. So since we are not rejecting H0, so whether it's possible, the answer is it's not possible that a type 1 error can be made. Got the idea? Listen to me again. Type 1 error is about rejection of H0. We are not rejecting H0, therefore not possible to make type 1 error. As simple as this. So 4 questions down. Now we are moving to question number 5. And this question is about, this looks like linear combination. Now the question says, first of all, the heights in a large city are normally distributed with mean such and standard deviation such and such. Find the probability total height of 5 randomly chosen buildings in the city is more than 95. So the first part, it's about sum of normal variables. First of all, if I write H follows a normal distribution, 18.3, 2.5 square, and let X equals to sum of 5 heights of building, H1 plus H2 ... all the way till H5. So x follows a normal distribution 5 times 18.3 and 5 multiplied with 2.5 square. When you do the multiplication, this comes out to be 91.5 and this is 2.5 into 2.5 into 5. That comes out to be 31.25. That is the data that you have. And more than 95, probability x is greater than 95, probability z is greater than 95 minus 91.5 divided by square root of 31.25. And let's get the z value. Let's do the division and the square rooting. So this is 0.626. That is rule number 2. According to the way I've taught, that is 1 minus phi of 0.626. You go to the table, you do the subtraction, and this final answer comes out to be 2657, which boils down to 268, correct to 3 significant figures. So 2657, my bad. This is not 2675, this is 2657. And this comes out to be 0.266, correct to 3 SF. So this thing is done. That's the first part for 4 marks. Part B. Find the probability that the difference between the heights of two randomly chosen buildings in the city is less than 1 meter. So the difference between the heights of the two. So let me write the data again. H1 follows a normal distribution. H2 still follows the same normal distribution. Let y equals to H1 minus H2. First, let me do the working for this one. So now H1 is 18.3 and 2.5 square. If I'm not mistaken, let me double check. Yes. So this is 18.3 and 2.5 square. Y follows this thing. Y is H1 minus H2. Y follows a normal distribution. This will become 0 and this will be added up. So when this will be added up, that is 2.5 square, which is 6.25, 6.25, which is 12.5. So let me first write it. 6.25 plus 6.25 follows a normal distribution 0, 12.5. This is y. Now let me introduce another variable. Let w equals to H2 minus H1. Of course, it could be building 1 minus building 2 or building 2 minus building 1. So W still follows a normal distribution 0, 12.5. So there are two distributions that you have. Let me first shift this thing down like this and let me highlight it. So this is one distribution, this is the other distribution. Of course, just work for one. This is just to show that you should not forget that you have to consider two options. Now this difference is less than 1. So probability y is less than 1. Probability z is less than 1 minus 0 divided by square root of 12.5. And this comes out to be probability z is less than a value which is positive 283. So 0.283. Now when we go to the table, which I've already done, this value comes out to be 0.6115 or 61.15%. You can write it like this also. Now let me show it on a number line. It says the heights of the two randomly chosen building is less than 1 meter. So now this is less than 1 meter. So the scenario is that if I involve the normal distribution curve once again, and let me first get it right like this, and this thing is 61.15%. so now over here is this z value, which is how much? Which is 0.283, and that was corresponding to that thing less than 1. So now this region on the right, let me label it. So this purple region is 1 minus 0.6115, and this comes out to be, let me grab the calculator, 1 minus 0.6115, this comes out to be 0.3885. Similarly, you have this value over here, that is negative 0.283. Why am I saying this? Because you have to think about both the extremes. So therefore, the thing is, the difference between the heights is less than 1 meter. So this is one option. And when you do the working for the other part, so now over here, your value is on the reverse side, on the mirror image side. So either it's h1 minus h2, or this is h2 minus h1. And when they say it's less than 1 meter, that means the difference could lie between two values, and this is the region that they are talking about. So this region, let me highlight it first. So this region, let me make it bigger. So this difference is between, let me get it right. Okay, let me just draw a line like this so that it's all good. A little bit thinner. So now this is the region that we are looking for. So therefore this is 0.3885. Similarly, over here, this one is the same thing. That is also 0.3885. Therefore, this region in the middle should be alpha percent. So therefore, or decimals, whatever you want to call it. So therefore, 1 minus the summation of 0.3885 plus 0.3885. So let me double check. So this is 2 multiplied by 2 and then subtract 1. So this comes out to be 0.223 or 22.3%. So basically it's between the two extremes. Find the probability that the difference between the heights of the two randomly chosen building is less than this thing. So one building is higher, the other smaller. One is smaller, the other is higher. So one is probability y less than 1, that is all region. And the other one would be probability y greater than 1, that would be the other region. So what is exactly in between the two? So exactly in between the two is probability y lies between -1 and +1. So basically this is the region that you get, and that comes out to be 22.3%. So that is what we are looking for. Now let's move on to the next question. Now it's CRV. So therefore this is CRV. And the question says, in a game, a ball is rolled down a slope and along a track until it stops. So what is the question about? It's about rolling down a slope and along a track, the distance. That's what the function is for. The distance traveled by the ball is modeled by the random variable x with PDF such and such. Without calculation, explain why expectation of x is 2. Now, first of all, it's a quadratic function. It's a quadratic equation. And the roots of this quadratic equation are 1 and 3. The coefficient of x square is negative, therefore it's upside down. And it's between the full limits. So during this limit, x between 1 and 3, the function is symmetrical. That's the main thing, because we have seen questions which were quadratic, but they were not symmetrical for that particular range. So if I draw this thing, so the graph is something like this, and let me draw this portion like this. So this is something like this. And this is 1, and this is 3. And the mid value, the turning point, the x coordinate of turning point, that is halfway between the roots, 1 plus 3, that comes out to be 2. So therefore, expectation of x is equals to 2, because for any symmetrical distribution, I think you should know that expectation of x and median of x is the same, and normal distribution is one prime example of this. So expectation of x is 2. Show that k is 3/4. I think that's easy. Fx integrated between the limits. So now the small limit is 1. The lower limit is 1. The upper limit is 2. Minus k is on the outside. X minus 1, x minus 3. So this is x minus 1, x minus 3 dx, and it should equal to 1. So now let me do some calculations that involve the limits and the negative sign. So this will become 1 goes up, 3 goes down, and k becomes positive. So that's the first thing. And multiply it out. So this is x square minus 3x minus x, that's minus 4x plus 3 dx, and equate it to 1. That is x cube over 3 minus 4x square over 2 plus 3x between the limits. 3 goes down, 1 goes up, k goes over here equals to 1. So let's do a bit of working. This is k. This is 1 over 3, 4 over 3 is 2, and 3 into 1 is 3. So that is what you get in the first one. And what do you get in the second one? You plug in 3. 3 cubed, that's 27 over 3. And minus 2 multiplied by 3 square, which is 9. And 3 into 3 is 27. And you use a calculator and you do the simplification with or without a calculator. And 3 into 3 is not 27, this is 9. So I make those mistakes. That is 9 over here. And this is 1/3 and minus 2 and 3. And you simplify it. And then the value of k comes out to be 3/4. So that thing is done. What's the next part? Find variance of x. So now first find expectation of x. That's already given. That's good. Now find expectation of x square. That is x square into fx dx between the complete limits. What are the complete limits? That is 1 is the bottom, 3 is the top, and what else is there? We have the value of k. There is a minus sign, don't forget, minus 3/4. So this is minus and this is 3/4. First multiply x square into, what is the function? X square minus 4x plus 3. So that is x square minus 4x plus 3 dx. Bracket closed before this. So like this. Let me do one more step. That is 3/4. And 3 goes down, 1 goes up. This and this and this, it changes places. So therefore this becomes x square into x square is x4 minus 4x cube plus 3x square dx, and integrate, that is 3/4. That is x5 over 5 minus 4x4 over 4 plus 3x cube over 3. Between the limits, 3 is lower and 1 is upper. So now that was a bit of algebra and arithmetic and everything. So therefore, whatever this answer comes out to be, you will have this answer. And then finally, variance of x is expectation of x square minus square of expectation of x. So this is minus 2 square. This one is this thing minus this, and that would be variance of x, and you will get this answer. Now it says 4 marks all of a sudden. Now it says one turn consists of rolling the ball 3 times and noting the largest value of x obtained. So now 3 times. So as soon as I have seen this 3, I know that a binomial distribution will be created. That's the first thing that I notice. If the largest value of x is greater than 2.5, now this is CRV, greater than 2.5. That means probability x greater than 2.5. Therefore, 2.5 is the lower limit, 3 is the upper limit. Minus what is the value of k? The value of k is 3/4. So let me just shift it to the side. So this is 3/4. And your function is x square minus 4x plus 3. So this is x square minus 4x plus 3 dx. Now when you do this calculation, you write minus 3/4 becomes a plus 3/4. And the limits are, I'll change the limits a little bit. Yeah, let me change it now. So that there is the same thing, consistency between everything. So this is x square minus 4x plus 3 dx. Now integrate, that is 3/4. And this is x cube over 3 minus 4x square over 2. And that's already done initially. Plus 3x, was it done? No, in this part it was not done. In this part, yes, it was done. X cube over 3 minus 4x square over 2 plus 3x. Between the limits, 3 is down and 2.5 is up. And you do the calculation, and this comes out to be 0.15625. This is the exact value, or you can use the fraction also. Now, once you have this thing, what needs to be done? Now you have to create that binomial thingy. So that binomial thingy is about this thing, that you have x follows a binomial distribution 3, 0.15625. And it says if this largest value is greater than this, and find the probability. Now there's one more sentence that we need to underline. Find the probability on a particular turn the player scores a point. That means that scoring could be done on the first throw, or the scoring can be done on the second throw, or the scoring can be done on the third throw. So all these are possible. So calculate this, calculate this, calculate this, and add it up. That is x is greater than or equal to 1. That would be this plus this plus this. But why should I do this when I can comfortably calculate probability x is equals to 0? This is the alternative way, and which is 3C0, success 15625 raised to power of 0, and 1 minus 0.15625, that comes out to be 84375. So this is 0.84375. Now it looks not nice, so let me write it over here, 0.84375, and this thing is raised to power of 3. So now when this calculation is done, whatever answer comes out to be, leave it for right now. So therefore the alternative is 1 minus probability x is equals to 0 is probability x is greater than or equal to 1, and you get the answer for this particular part, which comes out to be 0.399. So that's how this question was done. A lot of time you see that CRV is related with binomial distribution. Just a small part. They just want to make sure that you 100% remember the concept, the knowledge of S1 is assumed for S2. That is one thing. Let me add one more. Knowledge of P1 and P3, it's also assumed for S2. So for S2, you need all this thing. Now question number 7 comes. What's the question all about? So now question number 7 says that the 2 ponds A and B contain a large number of fish. It is known that 2.4% of the fish in pond A are carp and 1.8% are carp, random samples of such and such. So it's all about some fish thing. So 2 ponds A and B, 2.4% and 1.8%, random sample of 50 from A and 60 from B are taken. So first of all, this is binomial as it is. That's the first thing. A follows a binomial distribution, so that is 50, 2.4%. B follows a binomial distribution, that is 60, 1.8%. Therefore, n is greater than 50. Now, even before that, let me first calculate expectation of x. Expectation of x is np. So you multiply the two, and this comes out to be 1.2. So this is not a actually, this is a. This is not x, this is a. Expectation of b, this comes out to be 60 multiplied by this thing, that comes out to be 1.08. So this is for 50 fish and 60 fish with the corresponding percentages. Use Poisson approximations to the following probabilities. So even before that, let me write this. Since n is greater than 50 and np is lesser than 5, therefore A follows a Poisson distribution with 1.2. Since n is greater than 50 and np is less than 5, therefore x follows, if B follows a Poisson distribution with 1.8. Now these two things are there. The sample contains at least 2 from A and at least 2 from B. Now, one of the conditions of Poisson distribution is independence. So, when we talk about Poisson distribution, and they have few criteria. So, one of them is random. That's about mean number of occurrences, and it's about singly, and it's about occurring at a constant rate, and one of them is the trials, not the trials, the mean number of occurrences are independent of one another. So now this is what I'm interested in, independent. And now we also know that if two events are independent, probability of A and B should equal probability of A into probability of B. So probability that A at least 2 greater than or equal to 2. It is 1 minus probability A is less than or equal to 1. Find it comfortably. So that is 1 minus e raised to power of minus 1.2, 1 plus 1.2, and this answer will come out. Similarly, probability B is greater than or equal to 2, which is 1 minus probability B is less than or equal to 1, which is 1 minus e raised to power of minus 1.8. 1 plus 1.8 power 1 over 1 factorial, and this answer will also come out. Therefore, when they say and, so this and means multiplication. So therefore, one answer is this particular one. Let me call this as one answer. Let me call this as the other answer. So therefore, probability of event 1 and event 2. That is multiplying these two probabilities. The first one is the purple one, the second one is the reddish one, and you multiply and you get your required answer. Don't forget to round it off correct to 3 significant figures. So that's why it was for 3 marks. I mean, actually it should have been more than 3 marks. So now the sample contains at least 4 carp altogether. So now when they use the word altogether, that means it's a question of linear combination of Poisson variable. So therefore, A follows a Poisson distribution. Let me write it in black. A follows a Poisson distribution with 1.2. B follows a Poisson distribution with 1.8. Let W equals to A plus B. So W follows a Poisson distribution with 1.2 plus 1.8, which is 3.0. Sorry, it's not 1.8, it's I think 1.08. So I think I made a small error. Let me do the correction. This is 1.08. And over here, this is also 1.08 like this. So this is 1.08 and 1.08. And again, let me do the correction over here and over here. So this is 1.08, therefore 2.28. That is the new value of lambda. And then it says at least 4 carp. Probability W is greater than or equal to 4, which is 1 minus probability W is less than or equal to 3, which is 1 minus e raised to power of negative 2.28, 1 plus lambda square over 2 factorial and lambda cube over 3 factorial. So you do all this working and the final answer comes out to be 0.197, correct to 3 significant figures. So now that thing is done. So this question was about Poisson and it was the basics also, and it was about total also. It was about basics of S1, and now it would be something about algebra. I think the S2 examiners are too obsessed with algebra. Let's see. So now this thing Poisson continues, and then the question says that we have this thing. The random variables x and y have distribution such and such. Now this is a totally different part. So let me erase this and let me write this thing like this because it's a different part. So this is Poisson. and this is different what do you call lambdas, and this thing different means and something like that. X follows a Poisson distribution with lambda. Y follows a Poisson distribution with mu. Probability x is equals to 0. Let me calculate it. That's e raised to power of minus lambda. Probability y is equals to 0. Let me calculate it. That is e raised to power of minus mu. Probability y is equals to 0. The whole thing square is e raised to power of minus mu square, which is e raised to power of minus 2 mu. Let me do it in steps very comfortably, very slowly. That is the first thing. And now what does it say? This is the first piece of info. This is the second piece of info. This is this one. So if I add it all up, what do I get? I have probability x is equals to 0 is probability y equals to 0, the whole thing square. Therefore, e raised to power of minus lambda is e raised to power of minus 2 mu. And now we are back to indices of basic maths. That is a raised to power of m is a raised to power of n. Therefore, m is equals to n. So what should I write? You would write therefore minus lambda is equals to minus 2 mu. So therefore lambda equals to 2 mu. That is your equation number 1. Got the idea? That's the first thing. Now let's move on. Probability x is equals to 2. So probability x equals to 2. That is e raised to power of minus lambda, lambda raised to power of 2 over 2 factorial. Next piece of info, probability y is equals to 1. Probability y equals to 1. That is e raised to power of minus lambda, lambda raised to power of 1 over 1 factorial. Probability y equals to 1, the whole thing square. That is what I'm teaching you. That is simplicity of work. Write it, space it out, think. So that's the logic that you will be using later in your life also. It's not just about S2, it's about all the way. So that is e raised to power of minus lambda, and lambda, the whole thing square, that is e raised to power of minus 2 lambda multiplied by lambda square. So this thing is also done. Now let me highlight this part also. So now you have this part and now you have this part. And what does it say? Probability x is equals to 2. So before that, this thing is this one. Probability x is equals to 2 is this, and this, where k is a non-zero constant, is this k multiplied by this thing. So probability x equals to 2 is k multiplied with probability y equals to 1, bracket closed and square. Let me double check it. Yes, it is. Now you have e raised to power of minus lambda. This is lambda square divided by 2 factorial is 2. K as it is. Probability y is equals to 1, e raised to power of minus 2 lambda, lambda square over nothing. Now what goes away? The lambda square disappears. E raised to power of minus lambda, and this thing will also disappear. But before that, we have to do some working. So first of all, write this thing as e raised to power of minus lambda divided by 2. That's k multiplied with e raised to power of minus lambda into e raised to power of minus lambda. Now these two would disappear. So what are you left with? You are left with k is equal to e raised to power of minus lambda divided by 2. So that is what you get. Now either you would plug in something over here, or this is the value of k, and can you make e raised to power of minus lambda the subject? So 2k is e raised to power of minus lambda. So let me stop the working over here. It's not over yet. What is the first condition that we have? The first condition that we have is lambda is equals to 2 mu. So over here, probability x is equals to 2. Let me double check. E raised to power of minus lambda, lambda square over 2 factorial. That is the first thing. Probability y is equals to 1. That is, and they are asking for what? They are asking for the value of k. Probability y is equals to 1 e raised to power of minus lambda. I'm reading it over here. Lambda power 1 over 1 factorial. And then you are squaring it also, right? So you're squaring it also, but k is not squared. So therefore, e raised to power of minus lambda becomes minus 2 lambda, lambda square, and so on. Now, lambda is 2 mu. I think I've mixed up the lambdas over here. This is not lambda, this is mu. So that's why this error was coming. And this is mu. So let me write it. E raised to power of minus mu, mu raised to power of 1 over 1 factorial, e raised to power of minus mu, and again lambda came in. This is mu. So e raised to power of minus mu, and this is mu square. So now let me do the working. Small errors do happen, that lambda and mu all messed up and mixed up. So therefore, probability x equals to 2 is k times probability y equals to 1, the whole thing square. So this is e raised to power of minus lambda, this is lambda square over 2 factorial, k as it is, this is e raised to power of minus 2 mu, and mu square divided by nothing because it's already squared and there is no factorial at the bottom. Now e raised to power of minus lambda is e raised to power of 2 mu. So actually, if I look closely, this was already proven. So let me cancel this based upon the result above. Now what am I left with? Lambda square over 2 is k times mu square. Now use this result. Lambda is equals to 2 mu. So lambda is 2 mu, the whole thing square divided by 2. That's k times mu square. So that therefore this is 4 mu square over 2 is k times mu square. Mu square cancel. Therefore k comes out to be a straightforward 2. So that is the working for this part, and that was all about it. So the February March 2022 paper variant 62 is all done. Take care.